Hi, so let's do it. Okay, so today we're going to talk about futex-way. I don't know if what you've noticed. For our first video, we spoke about do rate, second one pipe rate, and then today futex-way. There's a lot of weights here, and I genuinely feel like that's exactly what you need in order for you to to understand debugging or to understand the machine that you're utilizing. It's just very logical. So a futex rate, it's not necessarily complicated. Um, do it. It's a parent-child relationship. Pipe synchronization or pipe rate. It led us to realizing that we're talking about a communication or a wire between two processes or thread. All right, it's the thin line between two processes, and it breaks. It gets full. The very same way our phones do when you leave a lot of messages, or at least that's what I think they do. And then today we are addressing futex rate. Futex rate is not necessarily complicated. It's essentially a thread that put itself to sleep, waiting for its turn, for access over shared resources. Alright, and for it, I usually have like this analogy, and that's the very first thing that came to mind when I tried to to understand what is happening here and how everything works. I had the bathroom analogy, and I think the script that I'm going to utilize will most definitely show you that because when I was creating all of this, that's the only thing that I had in mind. A futex rate is essentially a thread that puts itself to sleep, waiting for its turn over a shared resource. Alright, and what came to mind was a bathroom. Think of a bathroom if you are in a workspace and you have a colleague that goes to the bathroom and they lock themselves in. And the second colleague goes and tries to access the door and realize, whoa, well, it's locked, it's occupied. And instead of making noise and being very loud about it, spinning, consuming a lot of power and electricity, power and CPU power, what they do is they go go to sleep. They take a cue and say, well, please do let me know when she's done or he's done. I'll wait for my turn. Futex way. They are essentially waiting. That's right there. One, we have a lock holder. Two, we have someone who's taking queue, waiting to access the very same thing. So how we go about it is, here's the script. Contention. I think I misread. There you go. See, all these threads right here are trying to enter the same bathroom, and it's we only have one holder to it. So therefore, let's do our investigation. P contention. Right, that's the PID. In vein, we have to futex-hunt. Futex-hunt. Ooh, there you go. Here, the problem. Here, the solution. And what do we have? So we get the PID of the process. We get to find out how many threads are waiting on futex. So there's a lot. And then we have the address where the address they're waiting for. In this case, you could say the bathroom that they are trying to access. Alright, and then here we get to find the holder. Who's holding, who's locking, who has locked themselves inside the bathroom, and what are they waiting for? Okay, wait working. So in this case, they are waiting to be working, and partly the reason is the script that we wrote. Essentially, I have to wake this thing up. The holder lock held indefinitely. Press enter to release the lock. And the reason why this is the case is initially while we were building all of this right in here, we had a script that would last for like 30 seconds, and that was very short for me because I was still like typing things manually. And then it was 10 seconds, and then I increased that to 30 seconds, and I was like, well, let's just make it indefinitely so that I can be very much comfortable with typing and hunting and build the logic, the mental model. So yeah, this is why it holds the lock indefinitely, and this is how you hunt for essentially all of this right in here. Fortunately, if you wanted to fix this issue, you're gonna terminate the session. Even if you were to kill 9 or 15 the application crashes. Boom, terminated. So I'm still going to figure out or try to like to find the best ways. And if I think we have read it, they said if the application or if the code was not written to, I think it has something to do with just how the code is written. And here, yep, this is how you do it. Manually, you would, come on, we're gonna have to close the contention again, and then manually cut Python. Wait, but no, we're not looking for Python, we're looking for contention. Contention, but we're spelling contention. All right, and ask what are you doing, slipping, what are you waiting for, futex, wait. So as soon as that happens, okay, so you could possibly have a futex lock. How many threads? 1001. We definitely have one. So in this case, we need to find the address of the lock. Address. Boom. There you go. So now we have the address where all this commotion is taking place. And now we need to find the holder. So firstly, the address, and then PID, and then the address. There you go. And interpretation, waiting for interactive. Terminal input, press enter. Ooh, press enter. Yes, we need to press enter. That's it, to release the lock. This is how you do it. There's the script. Unfortunately, this right here is already, it's a script on its own. Mini script, hunting for how many threads are waiting on futex. This is also a script on its own, finding the address, and then this is also a script again. So this right here is essentially this is the sum of all of this right in here. We need to include the new PID. Boom. Alright, and it takes a while. It might be in microseconds. I don't know how many seconds, microseconds, but really it's stagnates a bit. But there you go. This is how you deal with the futex-hunt. So we've already done do it, pipe rate, and now this is the futex rate. Kudos.